Hello, good day viewers. In this tutorial, we are going to find a solution to this logarithmic inequality, which is the log of x squared divided by x plus 6 with the base of 3 greater or equal to 1. All right, let's get started. Let's start with domain. Remember, the input must always be positive number greater than 0. Therefore, x squared divided by x plus 6 must always be greater than 0. You should know that this is a rational function. We don't want the bottom to be equal to 0. So which value of x will make this statement equal to 0 is when x is equal to -6, right? So we don't want this value. And you should know that any real number you plug in here, whether it is negative or positive, the square will transform it to positive number. But whether it is positive, if the bottom is negative, positive divided by negative will still be negative. But we want it to be positive always. So how can we make the bottom to always be positive? It is when x is greater than -6. So this is going to be our domain. All right, so let's continue. You should remember that if you have log of b with the base of a, maybe if this is greater than c, if this a is greater than 1, then b must be greater than a to the power of c. So if you relate it to what we have here, you can see the base here is greater than 1. Therefore, x squared divided by x plus 6 must be greater or equal to 3 to the power of 1. So we write it as x squared divided by x plus 6 greater or equal to 3 to the power of 1, which is still 3. We can take it to the left hand side. We have x squared divided by x plus 6 minus 3 as it crosses over. This is greater or equal to 0. And remember that we can rationalize it as 3 divided by 1. To make the denominators the same, we can multiply the top and the bottom by x plus 6. So let's do that. We have x squared divided by x plus 6 minus 3 multiplied by x plus 6 divided by x plus 6. This must be greater or equal to 0. Now we can add the top and take a single bottom. This is x squared minus 3 times x is 3x minus, because the minus is going to affect the 2 times inside the bracket, 3 times 6 is 18. This is divided by x plus 6 greater or equal to 0. This is a quadratic function which can be factorized. Think of two numbers you can multiply to get -18, but when you add them together, you get -3. The numbers are -6 and +3. So the top becomes x minus 6 multiplied by x plus 3 divided by x plus 6. This is greater or equal to 0. So you can see that the whole of this is positive because it is greater or equal to 0, right? So what condition? It is either if both the top and the bottom are positive or both of them are negative, because negative divided by negative is positive, right? So let's write the two conditions. It's either if x minus 6 multiplied by x plus 3 is greater or equal to 0, and x plus 6 is greater than 0. We cannot write it as greater or equal to 0 because we don't want it to be equal to 0. So let's start solving this one before we come back to the other condition. This is quadratic. We can draw the graph. If you have y and x-axis, the zeros of this will be 6 and -3. -3, and we have 6 here. The leading coefficient is positive because x times x is x squared. So it is going to be an open-up parabola, something like this. So we are talking about the regions where it is greater than 0 above x-axis. So something like this, something like this. So we have the solution to be from -infinity down to -3, including -3, union from 6 down to +infinity. And the other one, taking +6 to the other side, it becomes negative, so x is greater than -6. So now let us take the intersection between this and this. You can see that This is from negative infinity down to negative 3. But because of this, which stated that x is greater than negative 6, we have to start from negative 6 down to negative 3. So x belongs to the set of values from negative 6 down to negative 3, including negative 3, union from 6 down to positive infinity. So this is the first solution. We don't know whether we're going to get another solution, but let's try. We're going to take the second condition where both the top and the bottom are negative. If x minus 6 multiplied by x plus 3 is negative and x plus 6 is also negative, right? So unlike the previous one, which start from negative infinity to positive infinity, you can still draw it if you want to. This is negative 3, this is positive 6, something like this. We are talking about less than 0, so everything here from negative 3 down to 6. So x belongs to the set of values from negative 3 down to 6, inclusive. Then the other one, if you solve this one, you're going to get x less than negative 6. X less than negative 6. But we don't have any intersection because if you look at it on the number line, we have 6 here, we have negative 3 here, we have negative somewhere here, negative 6. So for this, it is looking toward the left-hand side. But for this, it is a closed interval from negative 3 down to 6. You see, we don't have any intersection. So we are going to discard this solution and consider the first one. So our solution is x belongs to the set of values from negative 6 down to negative 3 union from 6 down to positive infinity. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.